Hello everyone, my name is Shipra Erin and today I am going to demonstrate the credit card fraud detection system. This application leverages Docker, Python, Flask, Kafka and machine learning to detect fraudulent transactions in real time. This is the code repo for this application, and this is a README file which basically uh, steps or write down all the things used, starting from system architecture, project structure, setup installation steps. If you would like to run this locally or using Docker, what was the process in selecting the model and training the model, what are all API endpoints, how we can do the batch processing, how the Kafka integration works, what is the front end interface like, what features are at the front end interface, how you can contribute to this, is it licensed or not. So all this is listed down in this readme.file. But before that, what I would like to do, I would just like to uh, remove this model pkl, delete, move to recycle bin, scalar pkl, delete. So this is the model created, and let me just quickly show you that how we can create this model. So this is my model training.py file, which basically takes this credit card data from 2023 and train and basically create the model. So let me just quickly run this python model training.py. This will take some time to execute as the file here is very large. But before that, let's move to, like, till it happens, let me show you the other components of this application. So as I said that we like did this readme list down everything. So let's go to the system architecture. If I'll click on it, so this is a system architecture. In this application, we have a front-end service which can basically utilize this endpoint using Flask API, which is basically using the trained model and generating the predictabilities and permutations if the data is fraudulent or not. This endpoint, this Flask API has multiple API endpoints, which helps with Kafka as well. You can provide the real-time streaming data, you can upload a file, and you can directly call this API endpoint from another client. So via front end, via client API, via Kafka consumer producer, you can utilize this model. Uh, so as you can see here in this, so let me close this one, let me show you the project structure. As you can see that I have different components here, for API, for client, for front end, for dataset, for configuration. So to make it more structured, so in here I've listed down the steps to do the setup installation. Today I'll be showing my demo using Docker, so make sure that you have Docker and Docker Compose installed on your system. This is how you can run it locally. This is how you can run it via Docker. Again, the model training and selection. So this document here, model training and data selection, it lists down all the steps and all the research behind or decision behind selecting this model and the data set, what were the pros and cons of different models, and why I selected this model. So yeah, and what else? So yeah, this is the model training. As this is getting executed here. It will take some time to execute, but meanwhile let's wait here. Then the two files will be generated here. This is a client API. It has two endpoints, one where it simply just sorry, this is our API. It has two endpoints. One is predict, where it is just making a call, taking a request call where the request has JSON data. Then there is file upload API endpoint here, which takes file upload. In front end we have this index.html file, our HTML page, which allows user to upload this file. This is my script, which is calling this upload method, the backend method, which I showed you earlier. And let's move to the Docker files here. Okay, so this is my Docker API file to run the API requirements, what all softwares I required, where I am exposing this data. Same for client API, sorry, Docker file client, what softwares are required, how this is created. Let's go to Docker compose.yml. So my intention is to also use Zookeeper and Kafka, but for this demo I'm not using these two. I'm just showing how we can just utilize the API using front-end endpoint via front-end. So this is listed here. The model training is taking some time, so yeah, that's what was I expecting, but let's hope that it finishes early. So if you have any questions, or if you would like to contribute to this application, I will soon be uploading it to GitHub. You can make a clone or create a pull request to suggest to make any suggestions. That will be that will be really good for this application. And if you have any questions, feel free to reach out to me. Let's hope that this runs, but let me show you the Docker container. As you can see that right now we don't have any container or builds or images. I've cleaned everything for this demo. Let's hope the model training works.